Hey guys, today we're talking about lines and kind of moving into our graphing section of linear functions. So this is kind of where we're going to dive head in and spend the rest of our semester dealing with properties of lines, graphing lines, things like that. So first off, I want to start off with what is a line? What's the definition of a line? Well, if we look at it, a line is a graph. Oops, there we go. A graph that has no curves. A graph that has no curves. So a line is not going to have any curves. So if we have our x and y axis here, we could have a line going like this, right through the origin, as long as it's straight. We could have a line maybe going the opposite way. We'll talk about lines going this way. Lines can go in any direction as long as they are straight. The most common form of the form that you'll probably like the best is called Slope-Intercept Form. It's written in the form y equals mx plus b. And the cool thing about this is, and the reason it's called Slope-Intercept Form, let me write that to the side. Slope-Intercept Form. The reason it's called this is because it gives us a slope, which is our m, and it also gives us an intercept, and it gives us a y-intercept, which is our b. So it lays everything out, and if you have an equation in slope-intercept form, it's going to be the easiest to graph, and you usually want to make it any of the other forms go to this slope-intercept form, which again is y equals mx plus b. And we touched on this a little bit with our direct variation when we had the equation y equals kx, and we talked about how k was kind of the exact same thing as m. It's the same thing as slope, but the only difference was it didn't have a b. So like when we had the equation y equals kx, this k is the same as slope, but we weren't adding anything. There was nothing over here that we were adding. That's because this always went through the origin. When we have a b, that's what makes our line not go through the origin. We could have it going through anywhere else, something like that. Notice it goes through the y here. It's not going through that origin. So the b is what shifts it up and down on the y-axis. This axis here moves your line up and down. I'm going to kind of play with it with Desmos here in a second. So anyway, slope-intercept form, y equals mx plus b. Our m is our slope. And again, since we're math people, we like to make 82,000 different names for the same exact thing. So you might hear slope, you might hear rate of change, you might hear y per x, rise over run. That's probably one you've heard a lot, especially last year. The formula for finding slope is y2 minus y1 over x2 minus x1. We're not going to do it that way. I've got a fancy way on Desmos to show you. We're going to cheat and not have to do the whole formula. And then you also might hear change in y over change in x. All of these things mean the same exact thing as slope. That's what m is, slope. Now your b, like I said, this is your y-intercept. Some words for this might be initial value, beginning. Go back. Or maybe starting value, something like that. So again, slope is your rate of change. Your slope is what's going to make the steepness of the graph less steep, more steep. If you think of a ski slope, you've got green, blue, blacks, double black diamond, all these different colors, and those mean the different slopes. So if you're a beginner, you don't want to get on the double black diamond slope because you're going to be going way too fast and crash. You want to start in the greens because they have a lesser slope. So steepness, slope is talking about the steepness. Again, your y-intercept or your B is where it crosses that y line. It's crossing your y-axis. So that's like it. If it were plus 2, it would start way up here. If it were minus 2, it'd start way down here. If there was nothing there, it was 0, it'd start right there. It determines where you start. So slope is the steepness, while your y-intercept shows where you start. What makes something linear? And the reason something becomes linear and there's no curve involved in it is because it has a constant increase or decrease. It has to be, the key word here is constant. It has to be a constant increase or a constant decrease. That's what makes it not have the curves. If you speed up, slow down, go really quickly, it's going to make it have sort of a curve into it. If it's constant, it's going to stay at that constant rate going up or constant rate going down. So practice, it says, circle the linear functions if they're not linear, why? So let's circle the linear functions. So this first one's a graph. It's a graph of a parabola. We've been looking at these with domain and range. This is not linear. It's not a line. It's because of what's happening down here. What's happening? There's a curve. So it kind of looks like it's constant, and then all of a sudden it makes a curve. So this is no curve. So this one's not linear. This one is a line. It has a constant rate. I'm going up at a constant rate. So we're going to circle that guy. So graphs are pretty easy. It has a curve. It's not linear. If it doesn't have a curve, then it is linear. So when you have a table, though, we need to look at your difference in your x's and your difference in your y's, and they need to be constant throughout. So like to get from the first x to the second x was that I had to add plus 2. To get from my second x to my third x, I had to add plus 2. Third to fourth, I added plus 2. So that's constant, but I also have to check my y's to get to 2 to 9, plus 7. 9 to 11. 9 to 20 is plus 11. 20 to 35 is plus 15. So if you notice what's going on down here is that these are all different. So this is not a linear equation because they're all different. If it were linear, these would all have to be the same and these would all have to be the same. When we look at equations to see if something is linear, x cannot be in the denominator of the fraction. So if x is anywhere in your denominator of a fraction, it is not linear. And again, if you were to graph this in Desmos, That's what that looks like. Notice the curves. This is not linear. So if you're ever not sure, you can always graph. But x cannot be in the denominator. If we look at this guy, you cannot have a square root. X cannot have a square root. This is going to kind of look like a shooting star on your graph. Equals square root of x, so it kind of starts at the origin and it shoots off. It's kind of like a shooting star and it goes on forever, kind of like that. It's a half a parabola, sort of sideways parabola. Let's look at this next one. We've got y equals 3.8. This is a function. Notice x is not in the denominator. It's not a, it's not a square root. Y equals 3.8. And we're really looking for it to be in this form of y equals mx plus b. And the reason here, this kind of doesn't look normal. I've got this b. Here's my b. That's 3.8. I'm missing this. And that's okay. That's just because I have 0 x's. 0 x's. So I don't have to put it. If I have 0 x's, why would I waste my time and put it there? I don't have to put it there. But it is in that form y equals mx plus b, where these were not. These had a square root. Did not look like this. There's no square root in these. There's no x at the bottom. X is on top, with right next to the m, always, 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 always next to your slope. So even though this looks a little bit different, it's just saying there's 0 x's, so why put it there? So all we did was put the b. And if you were to graph this, this is going to be a straight horizontal line through 3.8 on your y-axis. 0.8. If I were to, going the wrong way. It's just a straight line there, because there, if you think about it, there's 0 x's. 0 was in the place of my slope, so there's a 0 slope. There's no slope. So if we're going skiing and I said 0 slope, it's flat ground. And look, this is flat ground, right? There's 0 slope. 0 x's. Y equals 3, and this is in the exponent, so it's 3 to the power of x. This is no. You can't have an exponent. Again, because we're following this form, there's no exponents. X is not an exponent. X is just a regular down there. This guy. What I want to do first is simplify him to make him look a little bit prettier. Because anytime we have parentheses, we know we have to simplify. So I'm going to multiply that 6 out. Y equals 6 times x is 6x. 6 times -1 is -6. Y'all, this looks exactly like y equals mx plus b. Right? My m. There's my b. That is perfect. So this would be, yes, this is a function. Again, this has x squared, no exponent. So in all those equations, all we were looking for was to have the form y equals mx plus b. So no exponents, no square roots, no x's in the denominator, nothing like that. I want to kind of talk about slope. So you probably talked about positive and negative slopes last year, but you have not talked about zero under undefined slopes. I have a really cringy video for you guys that I think will help. And it's going to be really stupid, but for some reason it sticks. I don't know why, but it just kind of sticks with you after you watch it. I think because it's so cringy and his voice is kind of creepy. But here we go. Here's the video.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative. Nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined! This has been the Adventure Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined! The uphill is a slope with a positive number, the downhill is a slope with a negative number, the flat part is a slope of zero, and the straight up and down or vertical part is undefined. This has been the Adventure of Slope Dude. Thanks for viewing.
Okay, so I told y'all it was really cringy, but again, for some reason, it sticks and you will always remember it. So something I would write on my paper always is just draw that little mountain thing he had, super easy to draw, and then just fill it in. Puff puff positive, nice negative, zero fun, undefined. And that way you have this model of what everything should look like, which way every line should go. So first we're talking about the positive, and again, look here, it's puff puff positive. We're going up the mountain, puff puff positive, up the mountain. So lines go this way when they're positive. They're getting bigger. So a positive slope is going to be going this way, up. Negative slope, if we look at our picture, is going the opposite way. We're going down, nice negative, all the way down. So we've got positive and negative. And again, these can be moved around. You could have it down here. We could have it, oops. You could have it go, oops, not that way. Go through the origin. You could have it way up here, as long as it's going the negative direction. And again, the slopes could change. So you could have a really, really steep slope, or you could have that beginner slope. But as long as the direction is going the same way. So there is our negative. Zero, this is zero fun, zero slope. We're on flat ground. So something like this, it's flat. And again, you could have it down here. We could have it directly on the X. Those are all zero slopes. This is all zero fun. And then lastly, undefined is the one that goes straight up and down. And again, this can be anywhere on your graph. But these go straight up and down, undefined. There is no slope. So real quick, going back to functions, looking at these lines, are all lines functions? So if we look at the first one, does it pass the vertical line test? Yes, it only goes through once, right? It passes vertical line test. Second one? Yes, passes vertical line test. Third one? Yep, passes vertical line test. What about undefined? If I drew a vertical line, notice it's touching here, it's touching here, it's touching here, it's touching here. It's going to touch all the way down that line. So my x's are repeating. So an undefined slope is not a function. So are all lines functions? No. Undefined is not. Okay, so it says, what is the slope of each lines below? We're going to use rise over run. That's how we find slope. Rise over run. And I always say you need to find two pretty points. And by pretty, I'm just meaning they come in contact with right here, something that's pretty. Something ugly would be in the middle that you can't count and tell exactly where it is. Pretty means like that's over 1, up 4. That's a pretty point. So first is to find pretty points on this blue line. So some that just automatically kind of jump out to me is this guy right here. And then this guy right here. And again, there's a couple more on here that you could use, but those are some pretty points on your graph. And again, it's rise over run. So I got to figure out how many I have to rise to get to my next point. So I'm going to rise 1. I'm still not there. Rise, whoops, stay there. And then I'm going to rise 2. Now I am where I need to be. Now I'm going to run over 1, over 2, over 3. So now I had to go up 2 from this first pretty point, and I had to go over 3. Now, notice on our line, all the negative numbers are over this way. All our positive numbers are over this way. So if I go to the left, it's going to be minus or negative. If I go to the right, it's going to be positive, and I had to go to the left. So it's a negative 3. And again, we said it's what over what? Rise over run. Well, I rose positive 2 over negative 3. So that would be my slope of the line, negative 2/3. And if you think about it, my slope, dude, negatives go this way. Is that what my line's doing down here? Is it going the right direction? Yeah, it's a negative line. So if you ever get a positive or a negative when the line's not going that way, you can always double check yourself. If we look at this one again, you're finding two pretty points. That sticks out to me and that sticks out to me. Again, there's more you could use. Rise 1, 2 over 1. And again, this time it's to the right, so it's plus 1. So if I did rise over run, I'm rising positive 2 and over 1. Well, 2 divided by 1 is just 2. There's my slope. Again, pretty points. That sticks out to me. That sticks out to me. Oops. I got to rise 1, 2, 3, 4, 5. Plus 5, and then over 1, 2, and it's to the left, so it's negative 2. Rise over run. Well, I had to go up 5 over negative 2, and that's as simplified as it gets. This one, that sticks out. That sticks out. I have to rise 1, positive 1, over 1, 2, 3, 4, 5. It's to the right, so it's positive 5. Rise over run. Rose positive 1 over positive 5, so 1/5 is my slope. What do you notice about the less steep and more steep lines? like, look at my fractions compared to, or my numbers below 0. Look at this. I've got negative 2/3, and the slope's kind of not as steep, and I've got 1/5. It's really not as steep. Whereas when I've got 2 and 5 over negative 2 really is, as a, if I turn it into a mixed number, it'd be 2.5, negative 2.5. Notice those are more steep. So if you've got anything below 0, it's going to be less steep. The greater or bigger your number is above 1 is going to make it more steep. Let's look at this page now. Identify the slope that contains the points given below. So this is where we use our formula. This is on your formula chart. It gives you this m equals y2 minus y1 equals x2 minus x1. So I always just label my points first. And I just call this x, y, x, y. But we've got 2, so I'm going to call this x1, y1, x2, y2. Now I'm just matching up where everything is going to go. So x1, x1, right? y1, y1, x2, x2, and then y2, y2. So now I'm just matching them up and putting them in. So y2 is negative 2 minus positive 1 over x2 is 3 minus a negative 5. And you can work it out, or if you want to plug it in Desmos, how you see it, you can plug it in. Oops, go away. Let's hide that. Negative 2. And I'd go ahead and do the fraction button just to go ahead and do the fraction button just to get the fraction going. And let's change this to negative 2 minus 1 over 3 minus parentheses negative 5. I get this, and again, let's change it into a fraction because you're going to want that for slope. So negative 3/8. And that's what I've gotten because negative 2 minus 1 is negative 3. 3 minus a negative is really 3 plus 5, which is 8, negative 3/8. So again, Desmos or not. Now, there's a really cool way to do it on Desmos where you don't have to do any of this work here. We're just going to use these points that were given to us. So here's what I want you to do. We're going to take our points, go to Desmos, and you're going to hit this plus button right here, and you're going to hit table. Here's our x values, here's our y values. So I'm going to put my x values in first. 4, 1 are my x values. Then I'm going to go match up with my y values. 4's y value is 9, and 1's y value is 0. Then down here, you're going to say y, and if you type 1, it'll automatically lower it down like that. You're going to put that little squiggly thing. You press the shift button for it, and then m x1 plus b. And if you notice, there's all this stuff, stats, and we really don't have to deal with that right now. We're going to talk about R here in a little bit. But if you look at this parameters, it has m equals 3, b equals negative 3. So it not only tells you the slope, it tells you the y-intercept. And if you look at the graph, let me pop that down. If you look at the graph, my y-intercept, here's my y-axis. This is where it crosses at negative 3. So it tells me that, and then it also tells me my rise over run, which is 3. So the answer to this one is 3. My slope is 3. And again, all we did was put it in the table. you hit plus button, then you hit table. Then we plugged in, it had our table, it had x1, y1, and we plugged in 4, 9, 1, 0. And then we typed in y1, squiggly, x1, oops, m, x1 plus b. If you remember this right here, you're golden. It does all the slope for you. And again, we got 3. Maybe I should write this in a different color. 3 as our answer. So like number 6, here's a table, or not number 6, number 7. All you're going to do is do it in Desmos. So plus button, table. All you need is 2 values. It doesn't matter which 2 they are. I'm just going to pick the first 2 because it's easy. So -5 and -3. -5's y is 10. -3's y is 6. Again, you only need 2 values to find slope, so you don't have to put in the whole table. It's a waste of time. Then I'm going to go down here, y, press the number 1, it'll automatically put it down low. Squiggly, and the squiggly I think can be found on here as well. Maybe. Yes, right here is a little squiggly. So squiggly, mx, hit the 1, it'll automatically put it low, plus b. Here is my slope is my m, -2, and my b, where it crosses the y-axis, is at 0. So my slope for this one is -2. This one. This one I would do pretty points, and I would look at rise, going up 2, and run 1, 2, 3, 4. And again, it's the right. So again, it's rise over run. I've got 2 over 4, which simplifies to 1/2. Same thing here. 1, 2, 3, 4. Rise 4 over +1. Rise over run. Rise 4 over 1. And again, this simplifies to 4. Another table, I'm going to take the first 2 points. You could take the last 2. It doesn't matter what points you take. But if I take this 2, I have to take this y to go with it. But it does not matter at all. I'm going to go to my table. 2, 4, 7, 14. Y1, ugly, mx1 plus b. M is 3.5, b is 0. So my slope is 3.5. And for slope, I really do want it in fraction format. It'll help us when graphing later on. So if you want to put 3.5 in here and hit the fancy fraction button and change it to 7/2, that would be awesome. That's why we're kind of getting to where I have been telling y'all fractions are kind of important. We're kind of getting into that point where if it's in a decimal, you're not going to know what to do with it. Okay, so let's look at some of these. It says identify the slope and y-intercept. Make this a little bit bigger for y'all. The slope and y-intercept of each of the linear functions below. John began with $75 in his savings account and deposited $20 per month. So our 2 numbers are this. So I know one's my slope, one's my y-intercept, right? Well, he began with. That's our starting initial point. So that's my y-intercept. Right? My y-intercept is the 75. My slope is the $20. And if you think about it, because that's per means to multiply, so it's 20 times x, however many months. So whatever's next to that word that means multiplication is always my slope. Riley began with 300 baseball cards. Again, began, that's my y-intercept. He gave 10 to each. Each is a multiplication word. So 10x, so 10 is my slope. Ashley's car cost $1,200 and she made monthly payments of $300. So her starting out, she's kind of owes $12,000. So y-intercept, we're starting, our initial value is we're starting at, she's got to pay this $12,000 off. Then she's making monthly payments. This means that she's paying what? $300 per month. Per means to multiply. So slope, what am I doing? Slope is $300. Yes. Okay, this one's just an equation. It wants us to find the slope. Well, slope, remember, y equals mx plus b. My slope is always right next to my x. Always right next to my x, right there. So my slope is -3. Whatever's right next to my x is always my slope. Even if I reverse this order and had this is still my slope because he is sitting right beside my x. Right beside my x. This guy. Notice this is not in the form y equals mx plus b. If it is not in this form, you cannot just read it off and say this is slope, this is y-intercept. First, you have to solve for y. Look, never goes away. Solve for y. Why do you think we do it every Friday? Equals -4. So I'm going to draw my line. I'm going to go y side and everything else side. Negative 2x can't stay, minus 2x. Got negative y equals -2x minus 4. I'm going to divide by -1. So I've got to divide everything by -1. So I'm left with y equals 2x plus 4. Now I can look at it and say, who's next to my x? 2. So I should have 2 as my slope. Same thing here. I've got to have y all by itself. So I've got to solve for y. Y, everything else. Well, I just have to divide by 4, and I get y equals -1/4 x. And notice what's next to my x? -1/4. So my slope is -1/4. What would be my b, my y-intercept? There's nothing here, so what would it be? 0, right? Y-intercept, there's nothing there, so it's 0. It's crossing through that origin. Okay, that's all I have for today. You do have homework located in Google Class, or not in Google Classroom, in Go Formative. 4.1 homework is in Go Formative. That needs to get completed, preferably by Sunday would be great. Thank y'all. Y'all have a great weekend.